2020.
All right. So how are you going to do Apple Watch programming on a Microsoft Surface?
I'll break it.
Actually, it would be very interesting to see if Hackintosh runs well on that.
Probably.
Is it a new one?
Yeah, it's the Surface Pro 3 i7.
So 2 seconds of battery life, but runs well otherwise?
No, it's actually got like 6 hours battery life.
Oh, really? That's pretty good. All right. Why isn't this on?
Didn't tell me to do it.
Well, I mean, it's on up there.
Oh, it's blue right now.
Now it should come on. All right. So this is the special topics course. This is just kind of the generic syllabus for it. Homework assignments, 45% of your grade, 15% pop quizzes, 20% midterm and final, the usual rigmarole. You will probably have at least one homework assignment per class, sometimes more than one per class. So we meet 3 times a week. So plan on spending a significant amount of time outside of class on homework. Most of the assignments, at least early on, will be relatively small since we're going to be spending the first portion of the semester learning Swift, which is going to be a newer programming language to most of you. Any of you in here programmed in Swift before? Anybody in here not know what Swift is? It's valid to say yes. Okay. All right, so, but ultimately we're going to be writing software for the Apple Watch in here. Out of curiosity, how many of you do not have convenient access to a Mac outside of our lab? Okay, well, you'll be able to do your homework in the lab, but you won't be able to do your homework in your underwear at home unless you have convenient access to the Mac. One thing that you might decide to look into that might be interesting is a project called Hackintosh, which is a bunch of tools for trying to get the Mac OS installed on a PC. I've seen it work reasonably well. It's a lot more evolved than it used to be. So, could try it.
Can I work on my homework in my underwear?
I don't have a problem with it. You'd probably want to clear that with Dr. Locklear first, but it's cool with me. So, just... Oh, and you can probably tell your parents the same thing. It's fine.
Okay.
All right, so questions about grading scale, blah, blah, blah. The normal jazz. All right, so technical prerequisite for the class is 250. I know some of you have not had that and asked to take the course anyways. That's fine. Just understand that those of you who are going to be doing that are going to be in 250 at the same time. So you'll be kind of learning your first syntax-based programming language with Java and also learning Swift kind of at the same time. That's okay. Java and Swift are actually quite similar to each other. We'll talk a little bit about that today. Then we'll kind of dive into stuff. Let's see. Let me go this route. If you go to Blackboard, first assignment's already up on there. Go under assignments. Once again, we'll be using Slack for all of my classes. So if you do not already have a account, visit cuwcs.slack.com, create an account on there. Go ahead and join the CSC390 channel, and I tell you what to post in there, and that'll just be your first grade. So all of you should be able to get that completed within the rest of the day probably. But it's due before class starts next time. You don't have to post anything on Blackboard. I'm just going to go into the grade book with Slack open right next to it. Anybody who's posted, I'll give you 100, and anybody who doesn't, I'll give you a 0, and I'll be ashamed of you. Because this literally takes all of 20 seconds. For those of you who have not used Slack before, which I should not be, I think all of you have. Conkle, have you used it? Okay. So I think everybody in here has used it, or, hey, Kyle, what's kicking? 1 for 1 already. 1 for 1. Nailed it. So, did you use Slack last semester or didn't get around to that? All right, so anyways, we'll be using it in here. I would recommend if you have I think they have the Android app as well, but get the smartphone app for it. Go in and set up notifications. I know some of you were complaining last semester that it was exploding as notifications were going off every 5 seconds. You can go in and change notifications on a per channel basis. So I would recommend just going in and turning off all notifications, then going back in and just turning them on for the specific ones you might care about. That is maybe the courses you're enrolled in, and then also if you join any private groups for like study, working on homework collaboration, that kind of stuff. So I'd encourage you to take advantage of Slack, especially in here with the homework assignments, because there's the collaboration on the assignments with dealing with a language that most of you aren't familiar with is going to be beneficial. Okay, and I don't really care if you collaborate on homework. I'll find out on the exams whether you're learning anything. All right, so I encourage you to work together and come up with some cool stuff. We're also going to be dealing with kind of an interesting transition here over the next probably, I don't know, let's say month or so. Right now, and I hope, well, I'll just throw it out there and then we'll work backwards from there. Right now, when you write an application for an Apple Watch, the application streams from your smartphone to the watch. Okay, so you're actually writing the application for the smartphone and then creating kind of a dummy interface for the watch, and everything streams to it. Okay, with iOS 9, which is already in beta 5 right now, and Apple Watch 2.0, which is in beta 5 right now, applications are going to be going native on the watch, which means you'll be able to do a lot more powerful stuff on the watch and kill your battery life even faster. Okay, it's the ultimate trade-off, right? It's actually interesting. I've been running Apple Watch 2.0 for a little bit now. I have time travel, which is true. It actually says time travel. But in any case, you can't downgrade from it. Once you move to Apple Watch 2.0 beta, you're stuck, and you can't go backwards. But I've gotten anywhere between amazing battery life to no battery life. Like I've had it last for 2 days, and I've had it last for 5 minutes, and I'm not exaggerating on either side of that. So it's the Apple way, is I guess what I might say. But in any case, we might have to do some interesting transition stuff over the next month or so. If we start getting into Apple Watch, actually writing some interface stuff for Apple Watch before the official version of Apple Watch 2.0 comes out, along with Xcode, which we'll talk about here in a few minutes. Without the release version of that supports it, we might have to kind of do the Apple Watch stuff the old way and then kind of transition to the new way. It's not going to be a humongous difference, but just keep in mind that you might learn one thing and then have to unlearn it and relearn the version 2.0 way of doing it. Okay, and we'll come back to this here in a second, but as always, I have all the streaming lectures up here on YouTube, and then also I have a Swift programming guide. If you click on this, it'll open up a link. In theory, it'll open up a link to Apple's site for Swift stuff. Okay, so having said that, let me go ahead and start a presentation dealy flippy thingy here. Okay, so I want to review a couple things so we kind of see where these things fit in the world. For starters, and most of you have seen this in one of the classes you had with me, we've talked about kind of the lineage of programming languages, right? Trying to understand where our languages came from, because Swift is, out of all the languages that most of us have been exposed to, Swift is the newest of all these languages, okay? If some of you deal with some of the newer web stuff, there might be a couple languages that are younger, but in general, Swift is going to be our most modern language. I like to kind of start this chart off by looking at the C programming language, and we'll review some of the stuff since some of you haven't seen it in a couple of years. Okay, so we start at C, and I like to look at C as kind of the core of the evolution of all of our languages. even though C was not the first programming language. But all of our languages today take a lot from the C programming language. Okay, so I'm going to have two sides to the coin here. I'm going to have the native languages here on the right, and then I'm going to have web languages on the left, and then we'll kind of see where they come together, and we're going to see Apple's little evil plan. Okay, out of curiosity, how many, I mean, obviously you took the class because you get credit for it, and Apple Watch programming seems like it might be kind of fun, but how many of you are Apple haters? Or at least not Apple lovers? Let's go that route. Hate's such a strong word, right? Well, so okay, so you don't like Macs, or you do like Macs?
I don't really care for Mac.
You don't care for Macs, but you like Apple.
Yeah.
Okay.
Well, kind of.
What do you like from Apple?
Certain products like mobile devices.
Okay, so
I just,
iPhone and iPod Touch
yeah.
and iPods, music-y
Yeah,
stuff.
You classify me in the other category too.
Well, I don't know.
Okay, well.
Why don't you like Macs?
They're expensive.
Okay.
What can you do on a Mac that you can't do on Windows?
What can you do on a Mac?
What can't you do on a Mac that you can?
What can you do on a Mac that you can't do on Windows?
Xcode programming for iPhone.
It's because Apple's just a stickler, though.
No, Xamarin won't let you do. Yeah, it won't let you do native iPhone programming.
No, you can't do native.
Yeah, so there's your answer. Got it on the first try. So yeah. So my argument typically is, I mean, I don't disagree with you. I mean, anytime in computer science, you always want to deal with the right tool for the job. What I typically, if Grandpa's buying a computer and all he's going to do is check his email on it, Mac is not the right. Why spend so much money on something when you can just get him a budget pleaser, HP or something, and be done with it? But for a technologist like all of us, a Mac is really two machines for the price of 1.7. Is the reality of things. Like I mentioned a few minutes ago, if you're willing to go jump through some hoops, or you hate Apple that much, there are projects out there. The one I promoted to you was what's called Hackintosh, which I actually have a developer who's working with me who uses Hackintosh successfully for doing iPhone stuff. So it is a possibility, but it's one of those things that's tough to configure. But for technologists, where you are going to have to be working with a whole bunch of different technologies, I think a Mac makes perfect sense, and really it is two machines for the price of 1.7. With that in mind, it actually is inexpensive, when you consider it that way.
If you don't build your own computer.
Oh, well, what do you mean if you don't build your own
Because you
computer?
can save a lot of money by building your own computer.
Well, that's fine, but you can't build your own Mac.
Yeah, that's the point.
You can't build your own laptop.
Yeah.
Yeah, you sort of can do that. There's kits.
There-
There's nobody does it, but there are kits. But the punchline is, it's always about the right tool for the job. I'm a big advocate of right tool for the job, not necessarily. A lot of folks are often surprised when they assume I'm a Apple fanboy. I'm really not. I happen to have a lot of Apple stuff because I'm constantly going back and forth between .NET programming and things like that. But a computer, it's got the same crap inside of it. Literally the same crap. So at the end of the day, it all comes back to the argument between Apple and Microsoft, where Apple put proprietary stuff, or whether or not they were going to let their operating system run on something else. We wouldn't have any problem if Apple just let that release. But then what you'd have is probably a buggier Mac OS, because right now the Mac OS runs very smoothly, and people say, oh, my Mac is better than your computer because your computer crashes all the time, blah, blah, blah. Well, Apple's writing their software for 4 machines. Microsoft writes their software for 4,000 machines. No wonder it's a little bit quirkier, right? So, it's the trade-off, but, it's, so, okay, so you are in the Apple hater group. Who else was an Apple hater? Okay, well, anybody in here an Apple, I don't want to say lover, because that seems quirky, besides Yenter, but I hope that the mic didn't pick that up. Who likes Apple? Anybody here Apple fan? Okay, you like Apple? Even those of you in here with Apple laptops. So, Abe, you like Apple? All right. Well, why didn't you raise your hand?
I did.
It's not raising your hand. All right. So you have an Apple laptop. Okay. So now at the end of the day, when we're looking at these various technologies, whether we're lovers or haters, what I want to focus on in here is the language itself and kind of where this language came from. Okay, so we're looking at Swift specifically. And when we look at Swift, we want to look at the lineage where it came from and why it exists. Okay, so when we take C here, from C we went to C++. So what was the transition there? What happened between C and C++? Couple of plus signs, dude. I thought it was obvious. Okay, what was the transition here? Everybody, well, not everybody, a large percentage of you in here have had this exact lecture from me before. So suck less and answer the question. C is a procedural programming language. C++ is an object-oriented programming language. What's the difference? Yep, pile of wires versus something we always use the telephone as our example, right? So procedural languages expose all the details. Object-oriented languages, all they are is one more level of organization. It's like a piece of Tupperware. So C++ added to it this idea of an object, a class that allows us to shove all the details inside there, shut the lid, and then say, okay, it's all in there. Don't touch it. Don't touch it. Okay, that's C++. From C++, we transitioned, well, we'll just jump over here real quick because we can if we're going to color code this, orange is Microsoft. Why does it change the font when it's just dumb Apple products? And we'll say green is Apple, like green apple, did it? Haha. So when we transitioned from C to C++, Microsoft immediately jumped on the C++ bandwagon, and Apple immediately jumped on the bandwagon that Microsoft was not jumping on. Okay, so they jumped on behind a project called ObjectiveC. So ObjectiveC is the object-oriented version of C. Two similar but dissimilar languages based on C with slightly different syntaxes, but both with object-oriented extensions to the same core language. Fair enough? All right, so green is Apple. Now we're going to throw Java into the equation. Okay, so we throw Java down here. All right, what was the selling point of Java over C++?
Run on any machine.
Okay, write once, run anywhere. Platform independence. What was wrong with that idea?
You'd be running the Java virtual machine.
Okay, well, Java Virtual Machine was available for all the platforms, wasn't it? We can get Java Virtual Machines on the Mac. It's on Unix, it's on Linux, it's on PC. No harm, no foul. Inefficient, slow. Relatively slow. Computers are really fast. But Java originally touted itself, and it was probably a branding problem. Java originally touted itself as, well, we're going to bring video games to all the platforms. Because back then, when Java was first being announced, there was gaming was one of the main uses of computers. That's what people use computers for. We didn't see all these other pieces of our life that computers really could fit into, I guess. So they said, hey, we're going to have our video games that are available for all platforms. Okay, whether you're on a Mac or whether you're on a PC. What they forgot to tell you is that you have all these people who care about games, right? 98.5% of them were on PCs. Okay, and 1.5% of them were on Macs. And I'm being really generous to that 1.5%. Okay, it was probably less than that. Okay, but let's just say it was that. The Apple people were the only ones complaining. Okay, the PC people were perfectly happy. Their games ran on their stuff. Okay, so Apple people have always kind of been whiners when it comes to that. So how many of you have a Apple laptop but a gaming PC at home? I mean, if you're gonna do PC gaming, you don't do that on a Mac, right? Fine, there's plenty of games today that do run on the Mac. I mean, it's more common today. But because you don't have that ability to build your own machine and throw your own awesome graphics card in there and overspend on your processor and all this other stuff, because you don't have those options with a Mac, why do it? Why should I spend twice the money when I can build 3 times the machine for half the money? Makes perfect sense, right? Okay, but in any case, in Java's time frame when it was coming out, it was really pushing this idea that, oh, our video games are all in the future going to come out and everything, and you're going to be happy and it's going to be awesome. And I guarantee you do not want the latest version of Battlefield to be written in Java. All right, it would not function at all. Java's not meant to do that. Our computers are really, really, really fast, but Java is still running through a virtual machine. It's running through a piece of software that has to translate from Java bytecode into native instructions on the CPU for that computer. Okay? Nothing wrong with it. It's just relatively slow. Great for business applications. Great for Android applications. How many of you are Android users? Okay, every one of your Android apps is running inside of the Java virtual machine. 100% of them. And it's actually a really good thing for mobile applications, especially when you consider the stability you want from a mobile operating system. I mean, we want stability from all of our operating systems, but a mobile operating system, I would say, is especially important because you don't want your phone constantly resetting in your pocket and stuff like that, and you don't want to miss a phone call because your phone has crashed, right? you know, it can happen, but you don't want that stuff to occur. Well, the Android operating system maintains every part of an application runs in its own virtual machine. They have something in Android called an activity. An activity runs in its own micro virtual machine, separated from other activities that are in the same application. So even applications themselves can't crash each other, or can't crash themselves within the same screen, I think is the accurate way of putting it. But whatever. So it's not that Java sucks. It's the right tool for some jobs, is the punchline. Okay, so write once, run anywhere. What else did Java fix from C++? Quote, fix.
Just in time.
Well, actually, I mean,
Well, you're fixing the long compile.
yeah. I mean, let's not deviate from your just-in-time thing. Really, the just-in-time thing came from C#.
Yeah.
So C#, Microsoft stole Java, got sued, lost, came up with C#, which was basically Java with a slightly different syntax, but really one-upped Java with the idea of, hey, we have the ability to write once, run anywhere. Your C# code, you can write it one time. It'll run on any platform that supports the .NET component architecture, which is translated into it'll run on anything as long as it's Windows. Okay?
Hey, .NET is open source.
Nah.
On that,
Yeah.
comment.
Okay.
Comment.
Right. And that's actually going to be a big boon for Microsoft. But because the technology is already there for all the .NET languages to be platform independent. When you write code in Visual Studio, .NET code, it all compiles down to something called Missile code, Microsoft Intermediate Language, which is no different than Java bytecode. We can call those as kind of equivalent launching pads for the application running on the computer. Okay, it's an intermediate language. The difference is that with C#, the very first time you run that application, it takes a little bit longer to start because it uses a series of just-in-time compilers to convert Missile code into native code for that particular platform. And then from that point forward, every time you run that application, it's a native application.
Are you talking about an engine? N-G-E-N.
Well, that's new. Just-in-time compilers were the thing way before that.
There's that, and now there's engine too, which does it on install.
Right. Well, it's doing the same thing.
No.
It's compiling it just before you double-click it the first time. It's doing a pre-compile on install rather than a runtime.
Right. So rather than the long boot up.
At the end of the day, though, the difference is still the same, where with Java, every time you run a Java application, it is running through the interpreter. I use that term loosely, but it's not incorrect. Through the interpreter that is the Java virtual machine that is interpreting it for that platform in real time every time you run the application. Java did learn a little bit from Microsoft and went back and integrated some just-in-time stuff into their technology. So Java's not as slow as it used to be, but you have to consider that Java was built without the idea of a just-in-time compiler existing. C#, I think most people would say C# is the higher performance of the two languages, clearly. So punchline here is that At first, Microsoft tried to steal Java, lost the lawsuit, came out with C#. The Java people pointed and said, oh, you guys are just copycats. But in the end, C# actually turned out to be a pretty good product. Nothing wrong with it. Okay, but getting back to my question here, what else did Java solve relative to C++? So, fine, we'll say it fixed the whole platform independence thing, but was that really a problem? How many technologies today are platform independent? Or do we just say, look, if you want it to run on, if you want everything to run on PC. If you want to run less stuff, but have it your way, if you will, or I guess your way being Apple's way, as long as you're drinking the Kool-Aid, then use a Mac. The only people who cared about their stuff not being platform independent back there was the really small group of people who were Mac users, who thought Mac was so much better than everybody else's stuff, right? Well, I have news for you. Until OS X came out, the Mac OS was garbage. Okay? OS X is actually a great operating system, but it's not something that Apple made. It's something that Next Computers made. And we'll see that when we start getting into the Swift language. How many of you have heard of Next Computers? What is Next? Are you going to say they're the ones that did the OS? Or they're the ones you just said it? They're the ones that did the... Steve Jobs got canned from Apple, right? What, and founded a company? Actually, he did a couple things. He bought Pixar from George Lucas. George Lucas was going through a divorce, so bought Pixar for, I don't know, $15 or something. I want to say he bought it for like $11 million or something like that. Not a whole lot of money in the big scheme of what businesses cost. Later sold it to Disney for $8.4 billion and still stayed on the board as he basically still ran the company, but just had new cash in his pocket. Good deal there. But also, after he got fired from Apple, he went and founded his own company called Next Computers. And the idea behind Next Computers, it was supposed to be the best of both worlds. All the good things from Microsoft, all the good things from Apple, all put together in one pile that, you no longer have compatibility issues. Nobody used them except academia. I was at University of Illinois at the time, and it was they had a whole bunch of Next Computers there. That was 96-ish, 96-ish. But in any case, so then what happened is a lot of people are under the impression that Apple came crawling back to Steve Jobs and told him to come back, and they installed him as CEO when he was the interim CEO. And then he started putting I on the front of everything. Haha, iPod, What actually happened? Anybody know how Steve Jobs actually came back to Apple? Happens all the time. Apple acquired Next Computers. They bought the company. With the company comes its CEO. You can either fire the CEO or bring him in. So Steve Jobs came with the purchase of Next Computers by Apple Computer, was installed as interim CEO, paid Apple's payroll out of his own pocket because the company was going under. So it was, whatever. But the punchline is that all these new technologies that we've seen come out of Apple since then are actually things that came from Next Computers. So what we know as Apple today is really Next Computers with an Apple logo on it. And we see that even at the software level. We're going to see when we start getting into some of the different objects we use in Swift. Even this brand new language, we have things like NS strings, NS mutable arrays. NS is next step, all based from the next company. So, in any case, I would say Apple didn't get good until they bought Next and just rebranded that company that had better stuff. So, punchline there. But in any case, back to my question that you're avoiding. What did Java fix from C++? What's wrong with C++? Let's go backwards there. Huh? Pointers. Well, why are pointers bad? Aren't pointers cool? Real programmers use pointers.
Java doesn't. They
Well, but why?
Too much power for the stupid.
Too much power for the stupid.
Yes.
If you remove the object of pointers, pointing to pointers broken, is that what you're saying?
Well, I mean that's a fact, anyways. But the idea with C++, if we're going to say the problem with C++, was that with great power comes great responsibility. So C++ gave the programmer a lot of control over memory. As a programmer, you can decide you can manipulate memory all over the place, which was great if you knew what you were doing. It was dangerous if you're a beginning programmer or an incompetent programmer and randomly trying stuff, because now you're overwriting memory that you probably shouldn't be overwriting, like the memory that your operating system lives in. Okay? So people who were beginning, imagine that before the compilers got a little bit better and started running your C++ programs inside of really a virtual machine, if you will, to protect you from yourself. It was not uncommon years ago for you to, as a beginning programmer, be writing C++ code and literally have to reset the computer because you overwrote part of the operating system in memory. Because you forgot to, when you were working on your linked list, you forgot to disconnect some pointer, and all of a sudden half of Windows 3.1 is overwritten. Again, great responsibility. Great power comes with great responsibility. Java took a lot of that decision making away from the programmer. So we lost all the power when we went to Java. Let's say 98% of the time it's perfectly fine. I mean, I think Java is a really, really, really good language. It's a great teaching language for two reasons. One, we can focus on programming skills rather than what memory leak did you introduce and crash the computer. So we don't have to sit there and debug hard to find memory leak issues. And it's also platform independent even from the language perspective. So now I don't have to worry if you are a Mac user or a PC user or a Linux user. You can do your homework in any of those machines. As opposed to, as the example goes in here, half of you are going to be able to do your homework at home, half of you are going to come back, you're going to have to come in and use our lab here, and who knows, you're going to be able to log in down there. They are brand new machines, so they're really good. We have a whole bunch of really expensive new 27-inch iMacs we just installed over the summer. So even though they look the same, they're all brand new machines. But chances are we'll slow those down. We had to give some of them. We were originally planning on trying to sell them to students for like cheap, like $500. But we were asked by the people who approved the big budget for buying the new ones to hand them to like IT and stuff like that. So we had to give them away. Fair enough trade. Okay, so in any case, Java really protected the programmer from themselves. Took away some of the decision making, and rightly so. The example I usually use when I talk about that transition is in C++. You could do something along these lines. If you're having a party at your house, okay, and you're going to invite me to the party, C++ would allow you to hand me the house and tell me to open the door at 8. Okay, does that ever make sense in real life? It doesn't. Houses are expensive. They're heavy, right? From a computer perspective, they're really expensive because they weigh a lot. Okay, so none of us are going to be carrying around our house and handing it to somebody. Instead, we're going to hand them a piece of paper telling them the address of our house. Well, C++ let the programmer, empowered the programmer to decide which of those two they're going to do. Java, hey, we're passing a pointer to the house every time. You don't get to choose. It's a pointer to the house. But as Abe pointed out, Java doesn't have pointers, which that's going to be a problem in that case, right? In actuality, what does Java have? It's not that Java doesn't have pointers. Java actually is pretty much everything's a pointer in Java, so there's not a specific syntax for pointers in Java. And from a programmer's perspective, we don't have to make those decisions. Okay? So, in any case, continuing to go down the rabbit hole here, we have our kind of our modern languages. I usually refer to them as the big three. So we have Java, C#, and here we'll throw ObjectiveC 2.0. I mean, at least you got to give them that. Apple has always been so innovative with their naming conventions. We had Mac OS 6, Mac OS 7, Mac OS 8, Mac OS 9.
Yeah. Then you got Capitan.
Yeah, El Capitan. That
You can't even like.
then they started naming it after cats, right? So we had Mac OS X, and the whole question was, is this OS 10? Is the X for 10, or is it X for Unix? Because we just stole it from another company. Which is it? Because actually Mac OS X is based on OpenBSD Unix. It's not an upgrade to Mac OS 9. They basically just destroyed, well, they weren't even part of the same code base. They're completely a new operating system. Because how many of you ever used the very first Mac OS X? When you first got a machine with the first Mac OS X, none of your software from Mac OS 9 ran on it. Kind of like getting a PC today and you have a whole bunch of Mac software. It just won't run on it. Well, now you got a Mac, and you get a new Mac, and your stuff won't run on it. Wouldn't that kind of tick you off?
It's very frustrating.
So what did Apple do? They came out with something called the Blue Box, which was a virtual machine that allowed you to run Mac OS 9 inside of Mac OS X at a fifth of the speed. So you could run all your software that existed. You could run in the virtual machine at a fifth the speed it used to run it. And then you had the high-speed native Mac OS X that had no software for it, that you did nothing in. It was highly entertaining. But it was part of that transition that needed to happen. Because now, now Mac OS X is a very strong operating system. But there was a major time there where, is this going to work out? I know the Mac people are already drinking the Kool-Aid, but do they like it that much? It's like, okay, our beloved Apple just gave us a new operating system that doesn't run any of our old crap that we bought from them. And I mean, it's my understanding that Apple people pretty much just send Apple checks on a monthly basis, right? I mean, I think that's the way it works. I actually have it coming. It's an automatic bill pay out of my account, I think. But okay, so in any case, so the Apple side of things, ObjectiveC 2.0, very, then we have iOS 1, 2, 3, 4, 5, 6, 7, 8, 9. Why haven't they started naming those after like goldfish or something?
Google already did.
Yeah, Google does candy, but it was actually funny. Apple did kind of make fun of themselves before they announced Yosemite. Actually, what came before Yosemite? Maverick. Right before Mavericks. They had, because they were running out of cats. So at Apple's developer conference, they were like, we're starting to run out of cats because they got, lion and mountain lion, all those things. So then they put up, we were trying to think of options. They had this picture of a sea lion with a beach ball. So Mac OS X sea lion? Lion, mountain lion, sea lion. I would say sea lion's better than El Capitan. Right? So, whatever. But in any case, I'm going to say that these two languages over here were fairly archaic. I mean, it's not fair to put it before C++, but it's probably more fair to say Java and C# were, from an evolutionary perspective, more evolved than ObjectiveC 2.0. Okay? And people today still write ObjectiveC 2.0 code. In fact, until about a year ago, actually that's not even true. Until about 6 months ago, any application you were writing for iPhone, you would have written in ObjectiveC 2.0. Only recently, last 6 months or so, has Swift really kind of come into its own. And now if you're starting a brand new application, it's very likely you would write it in Swift for any of the Apple ecosystem stuff. I have a bunch of students that I mentor that work for Uber. And Uber's still all of ObjectiveC. They all do ObjectiveC. Just because they have a giant software base that's been written in ObjectiveC, and they're not going to switch to this new language. And it's even worse. Uber doesn't even use any of Apple's build tools. They do everything. They build all their interfaces programmatically, which is stupid, but whatever. So we have this little picture over here, and we'll go ahead and draw Swift in. So here's our shiny kid here, Swift. We got to color code that dude, right? All right. Okay. So Swift, super awesome, super new, blah blah blah. But why? Well, now I'm gonna do some other stuff over on this other side.
Is it not Apple?
It is Apple-ish. Oh, you got away from my punchline. Everything comes out of my mouth is gold. Okay, I guarantee it's going to be amazing. It's cold spit. I go to the pawn shop. I just spit in the guy's face, and he hands me a 50.
Gold vomit on your computer.
All right, so I'm going to call these our native application, or native languages over here. Now I'm going to write kind of a little lineage thing for web languages on this side. So I'm going to go back relatively far. We're going to throw Perl as our first, let's call it our first web language. It actually predated the internet, so Perl was really the first language that Unix system administrators kind of leveraged for doing webby type things as the internet was trying to decide whether it was going to be a thing or not. All right, so let's kind of not go too deep into that. From Perl, we had really our first web language specifically designed for web, and that would be PHP. From PHP, we had a language called Ruby, but nobody ever just calls it Ruby. It's always Ruby on Rails. What is Ruby on Rails? PHP on Apache. Love that. You paid attention in a different class. Okay, so with PHP, we used to have to configure a web server called Apache to run our PHP code. Well, Ruby came with its own web server called Rails. All right, so now you, as a software developer, you can just sit down and start writing web stuff rather than having to get a whole web server set up someplace to test your code on. You can just sit there and start working, and then as soon as everything was good, you would deploy your entire application someplace else. So it took out the IT side of web development when you were actually developing it. Eventually, you needed an IT skill set to get it hosted somewhere so that the world can see it. But with Ruby on Rails, you could write your application locally and test it from a web perspective and all that jazz. Then off Ruby, and I'm just gonna this is kind of where all these guys are kind of in the same melting pot. I'll throw Python in here. Okay, Python is really a standalone scripting language, kind of made popular by Google. But then the Python fanboys decided, hey, we want to be like the Ruby people, so we might say Ruby Rails, and then we would say Python. Anybody know the Python equivalent to Rails? Something called Flask. Okay, so they came out with a third-party library called Flask that allowed you to write Python code that ran in its own web server called Flask, just like the cool Ruby people. Okay? And then the cool kid right now on the web side of things is Node.js. Okay, Node.js is really JavaScript on Node. Node is the actual web server. So what's cool about this is all these languages up here are what are called backend languages. So these would be languages for writing your server side, or they would ultimately spit out HTML and JavaScript. JavaScript historically has been a front-end language. So, our web browsers understand HTML, right? Well, HTML itself is not a programming language. Why not? By my definition that I've taught you, why isn't HTML a programming language? What doesn't it do? Every one of you has seen a slide of how human beings solve problems and then the mapping between how human beings solve problems and what all programming languages have facilities for. Human beings solve problems by using our memory, asking questions, repetition. And I've advertised that 100% of programming languages will have facilities for those three things. Usually memory, it's variables. Asking questions is going to be conditionals, if statements. Repetition will be loops. How many of you know HTML? Okay. Can you do variables in HTML? No. Can you do if statements in HTML? Can you do loops in HTML?
Yes.
Not in HTML.
Yes, you can.
HTML5 HTML5 is a merger of Flash. Tell me how you do a loop in HTML.
In HTML, open up an iframe to the same page. Recursion.
That's recursion. That's not a loop.
Still loop.
Nah, loops do not use the stack by default.
All right, I'll give it.
Thank you.
Sort of. You said repetition, though. That's repetition.
But even then, I would still argue against that. HTML does not support repetition. It's the browser that's interpreting your HTML that's actually opening up the iframe. So you still lose. So in any case, HTML in itself is a data representation language. I think what you were thinking about is HTML5. That has all these other things built into it. HTML5 has become this conglomerate of HTML and what Flash used to do. Okay? The HTML-based language is actually a data representation language that our web browsers understand to make things look pretty on the screen. That's what HTML does. It's not that it's crappy. That's the job it's meant to solve. Therefore, we had to have this extra little dude hanging around, which is JavaScript, so that we can do dynamic programming type stuff on web pages. JavaScript lets us do variables, ask questions, do repetition through loops. That's what JavaScript did for us. So anybody who is a web programmer has been doing JavaScript for years and years and years and years because it's been around since the beginning of the internet. Okay? Well, with the new kid, Node.js, this guy right here, which I'm guessing is kind of getting small on the screen. New kid. Oh, look at that. That's awesome. No, good enough. All Node.js did is it said, oh, hey, by the way, you already knew JavaScript for your front-end stuff. Why don't we go ahead and let you write your back-end stuff in JavaScript as well? And we'll go ahead and give you a built-in web server called Node. So now you're a JavaScript programmer who's also a JavaScript programmer who's running it on Node. Really, this technology and both of these technologies are the same crap. Pick a programming language, run it in a web server, display HTML and JavaScript on the screen. Okay, they all do the same crap. Just the evolution of the technologies. Okay, so now the punchline here in our last couple minutes. Why Swift? Would you agree that given how old Objective-C was, that Apple was long overdue giving its language a facelift? How many of you have ever written code in Objective-C? Okay, Abe, a little bit. You had the iPhone class a while ago, way before Swift, right? Okay. Any sort of stuff you were reading online were the iPhone programmers complaining about Objective-C? Oh, they loved it. I mean, hey, when you're an Apple person and you're already drinking the Kool-Aid, you are drunk on the goodness. Okay? You are drunk on the goodness that is Apple. Nothing they can do, they can't do anything wrong. Who cares if your language is archaic? It's good that we understand it, and it's harder for those simpletons over there to pick it up because it just looks a little bit old. It just makes us better. You know, why should we? They weren't asking Apple to do anything. They were perfectly happy with the old language. In fact, I'll tell you what, I've been programming in Objective-C since the iPhone came out. I quite like the language. I use it in some of my 250 and 300 examples to show what's actually happening behind the hood. I think there's some legitimate advantages to Objective-C from a function perspective and how they have a whole, like when you initialize something, you say init with this and this and this, and it's a whole big old sentence. It's awesome. But it really does have its place. But the punchline here is that Apple did not come out with Swift to make these dudes happy. These dudes were already happy. Okay, the only people that ever left the iPhone ecosystem were people that Apple screwed over with their paid app. You know, a good example, I remember somebody came out with an app that allowed you to stream podcasts back in the early days of the App Store. Well, Apple had been working on their own version of that type of thing internally, but didn't tell anybody because Apple's secretive, right? So this guy had spent a year writing this application. It was really good. He submitted it to the App Store. Apple rejected it because it was too close to a similar product they were working on internally. So this guy went on a hate spree on. So he probably switched sides. But in general, people don't leave, right? Swift exists, and we'll just finish with this, to entice the Java people to come over to the dark side. Hey, you're an Android programmer? Why don't you take a look at Swift? It's not as scary as Objective-C. Come over and start writing for us. Hey, you're a Node.js or a Python or a Ruby programmer, and you're writing HTML5 mobile apps. Why don't you start writing native Swift apps for Apple? Swift targeted those folks, not the Objective-C folks. Wanted them to come over to the dark side. Make sense? All right, first assignment is up. It's the whole Slack thing. Make sure you do that. If you don't, I will criticize you publicly because I'm going to be using that quite often in class. All right, I will see everybody on Wednesday.
I've been playing around in the playground, learning some of the like syntax changes.